Alright, graphing two functions on the same axes. Because it's a graph, I just want some specific points. So I'm going, these x's as exponents can be any value. So I'm going to just make them -2 to +2 going by ones. So just make a table. If x is -2, y is 2 to the -2, which is 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the power of 1 is 2, and 2 to the power of 2 is 4. So what I'm going to get is this very predictable exponential function, really flat to the left. 2 to the third power is 8, and 2 to the fourth is 16, so it's going to increase so fast. So dotted asymptotes. Asymptote is my x-axis, so I guess my x-axis should be dotted. And my domain, x can be anything, XER, or you can write from -infinity to +infinity. My range is y is greater than 0, and the asymptote is where y equals 0. And that's the exponential function. And I could have just graphed that on my calculator, 2 to the power of x, and this is a -10 to +10, so that's Zoom 6 window. And you'll see it here, and that looks pretty much the same. All right, now y is log x base 2. You can't put on your calculator. So I think you should write it in exponential form, 2 to the power of y equals x. And then choose values for y and figure out what x is. So 2 to the -2, 1/4. 2 to the -1 is 1/2. 2 to the 0 is 1. 2 to the 1th is 2. 2 to the squared is 4. Gosh, it's just the opposite of this function. Huh. So here I get a 0.10. I get a 0.21. I get a 0.42. If I went on, I'd get the 0.83. So it would go up like this, and it goes straight down, and my asymptote is the y-axis. So for this one, domain, x has to be greater than 0, because you see it never becomes negative. My asymptote is at x equals 0. My range is y can be anything. And you will see that the domain of the exponential function is the range of the log function. The range of the exponential is the domain of the log. You're flipping x and y, that's because these two are inverse functions.